All right, our last sheet on slope intercept form word problems. This one is regarding what happens if you change the number for the y-intercept, what happens to the graph, or if you change the slope number, what happens to the graph, or what happens to the function itself. So I'm going to go through the two examples on the top of this sheet, followed by I'll work and guide you through numbers 1 and 2 and on that sheet, and then numbers 3, 4, and 5 you will be doing on your own. So let's take a look at the example at the top of this page. Please make sure that you have the worksheet in front of you so I can describe things to you. It'll make it much easier. Example 8. Abby is looking for a new cell phone provider. In her search, she has found a local company, Gift of Gab, that uses the function y equals 3/4 x plus 20 to model the monthly charges, where x represents the number of minutes used that month. If $20 were changed to $40, if $20 were changed to $40, how would the graph of the function change? All right, so what you're looking at is this 20 right here. This is your y-intercept. They're saying if this changes to 40. Let me show you over here to the right. Take a look. I have a graph over here that models that equation y equals 3/4 x plus 20. Plus 20 is your y-intercept. Notice I have a dot over here on the y-axis right at 20. And they're asking you, how would this graph change if the 20 would become a 40? Well, where is 40 compared to 20 on the graph? That's right, 40 would be above that. So the dot for the start of the graph would actually be higher on the graph. And since the slope didn't change for that, that line will run at the same rate. So then how does the graph change? It just starts higher on the graph. So we would say that the graph would start higher on the y-axis and the line would be above where the other one is. Notice they're parallel. Didn't change the slope, so how the line moved doesn't change, so they'll be parallel lines. It's just that since we changed the y-intercept, our starting spot, the graph is higher on the graph. The line is higher on the graph. So we would be over here at where 40 is instead of where 20 is. Okay? If you have any questions, please bring that to me. I'll be happy to explain it to you. Let's take a look at example 9. Example 9 says Jack Collins has two auto dealerships, one that sells only cars, and one that sells only trucks. Both dealerships' employees get paid a set salary plus a commission per car. All right, in a slope-intercept world, your set salary, that is your y-intercept. The commission per car, that is your slope. The car dealership employees get paid according to the given equation, P equals 20,000 plus 500x. And the truck dealership employees get paid according to the given equation, P equals 10,000 plus 1,000x, where x is the number of vehicles sold. So in other words, for each vehicle sold at a car dealership, the employee will get $500 extra. If he sells 2 cars, he gets $1,000. If he sells 3, he gets 1,500 extra. At the truck dealership, if he sells a truck, he doesn't get 500, he gets $1,000 instead of 500. He gets 1,000 per car. We're to compare the commission rate of the two dealerships. Step 1. The commission rate is what each employee gets paid per vehicle. In the two equations, it's represented by the slope, which is exactly what I was talking about here. So you have for the car dealership, they're paid $500 a car. For the truck dealership, they're paid $1,000 a car. Notice that's next X, that's your slope number. We're asked to compare these slopes. So I made a picture of the graphs over here. If you take a look of the first graph at the car dealership, that graph has a set salary. The car dealership. Yes, let me start again, please. My apologies. Let's look at the graphs. If we start with the car dealership, so that is the P equals 20,000 plus 500x. That would be this right here, starting at 20,000, and it's going up at 500x. So it's going up because it gains $500 per car sold. The other line I have on here, the blue line, that is for the equation for the trucks. P starts at 10,000 plus 1,000 per X. Notice it goes here, and notice this line goes up faster than the line that starts at 20,000. So what is the graph showing us? The graph is showing us that even though the truck dealership employee starts with a lower salary, the amount of salary they will gain will go up faster than those that work at the car dealership. And there is always eventually a point where working, if you sell enough cars at the truck dealership, that's the blue line, that would be ends up giving you a higher salary than if you worked at the car dealership. And that's what this is talking about. So when we read here step 2, compare the slope. The car dealership employee's equation, P equals 20,000 plus $500x, has a slope of 500. The truck dealership employee's equation, P equals 10,000 plus 1,000x, has a slope of 1,000. The truck dealership employee's commission rate is $500 more per vehicle. And because they get more per vehicle, the amount of pay they can gain will go up faster than those that are at the car dealership. Okay, I'm going to take you through problems 1 and 2 on this activity. And so let's take a look here. Number 1, the Ringles Rock Band charges a $300 setup fee. Now that's a setup fee. That means that fee isn't going to change. Plus a $175 per hour that they play. That one will, because it will the amount of money that they get paid depends upon how many hours they work. The total they can charge, C, can be found using the function C equals $175 per hour plus 300. Here's our question. If $175 were changed to 200, how would the graph of the function change? Let's look at which number they're changing. If you, in our equation, you have C, we're going to change that equation. Here's the original equation. C equals 175H plus 300. They're telling us in the word problem, they're saying change the 175 to 200. So 200H plus 300. The question then is, how would the graph change? So if here they changed the slope, it went from 175 to 200. Is 200 greater than 175 or less than 175? It is greater than. Since 200 is greater than 175, the line on the graph will be steeper. It will go up faster. Just like up here in the car dealership one, example 9, where the truck dealership has $1,000 commission. That's why that line goes up faster. Then the other one has 500. The line goes up, but it just doesn't go up as fast. So in problem 1, our answer here would be that how would the graph of the function change? The line moves up faster. The line is steeper. The line moves up faster. The line is steeper because the slope is greater than what it was to start with. All right, take a moment to write that down, that the line moves up faster and is steeper. Pause the video, please. Let's take a look at number 2 now. Sam's Towing Company charges can be found using the function y equals 3x plus 21. X is the number of miles a car is towed, and y is the total charges. If $21 were changed to $15, how would the graph of the function change? Now, where is the what number is being changed? Are we changing the slope or are we changing our intercept? If 21 were changed to 15, that means you are actually changing the intercept. So let's rewrite the function off to the side. The new function would look like this. Y equals 3x plus 15. So what does this mean for the graph? On the old graph, if I draw a quick graph here, you would have this. Here's your y-axis. Here's your x-axis. You would have a number, our original one, and I'll put this in the color blue, so the original line. So that would be starting here, and it's going to go up by like 3x, like this. All right, so our starting number, 21. Where is 15? Above 21 or below it? That's correct. It is below it. So then that means if you were to look at the graph for the line that says y equals 3x plus 15, it will start below the 21. It will go up at the same rate, so the two lines will be parallel because they'll have the same slope. This one has 3x plus 21, 3x plus 15. They're parallel lines because they're moving up at the same rate. They didn't change the charge for the number of miles, but they changed the starting charge. That means the graph for the when you change it to 15 starts lower on the y-axis. So what you want to write in this case is that you want to write down that because the y-intercept is less, the graph starts lower on the y-axis. Because the y-intercept is less, the graph starts lower on the y-axis. Please pause the video and write that down. Lastly, let's take a look just very briefly at 3, 4, and 5. What you'll notice is that these problems are very similar to numbers 1 or 2. One of the two, it's very much like them. So what you have to determine is, are they changing the slope or are they changing the y-intercept? If you're changing slope, that means the line will either go up faster or up slower. If I increase the slope, the line goes up faster. If I decrease the slope, the line goes up slower. If I deal with my y-intercept, in other words, where I start on a graph, like here, the last problem in number 2, if I decrease my y-intercept, the line starts lower. If I increase my y-intercept, the line starts higher on the y-axis. So take a look at 3, 4, and 5, read through those, figure out which of those situations are, and please make a description as to what happens to the graph based upon whether you've changed the slope or whether you've changed the y-intercept. Okay, thank you. Give those a try. Let me know if you need any help.